Find the inverse function for the given function f of x, and use the composition to verify that the functions are inverses, then graph. So in this case here, we got a couple of steps that we're going to start with. So first I'm going to find the inverse function. So I'm going to go y equals negative 3x plus 3. So I just flipped out the y. Now I'm going to solve for x here, which ends up giving me x equals y minus 3 over negative 3, which is going to give me y equals x minus 3 over negative 3, which gives me my inverse of x minus 3 over negative 3. So now I have my inverse. So I'm going to verify by using composition. So I'm going to take first my original function, which is this. And instead of plugging in x, I'm going to plug in the inverse function. So wherever I see x, I'm going to plug in the whole thing, the whole inverse function here. So I see negative 3 times x. So instead of x, I'm going to plug in x minus 3 over negative 3, and then add 3. So now instead of this being x here, I just plugged in the inverse function instead. So now I just want to solve this and figure out what this is equal to. I know that if I multiply by negative 3, it cancels this out, which leaves me with x minus 3 plus 3. Anytime I subtract 3 and then add it back, that leaves me with just x. If I do this composition and get just x, then I know, yes, I verified my function. The other thing that we want to do is we first took the original function and plugged in the inverse. Now I'm going to do the opposite. I'm going to take the inverse function and I'm going to plug in the original function. So in this case here, let me change colors here. So in this one, we're going to take the inverse function, but anywhere we see x, we're instead going to plug in this whole thing, f of x. So it starts off with x minus 3, but I'm going to take this whole thing here. I'm going to do it below to give us a little bit more space. Negative 3x plus 3. And now I'm finishing out the rest of the inverse function, so minus 3 over negative 3. Now I'm going to solve this here. I know that these parentheses go away because it's just a subtraction after this. And then adding 3 and subtracting 3 cancel each other out. And I get negative 3x over negative 3. These cancel out as well, leaving me with just x. And again, that's what I'm looking for. So that's how I verify my inverse functions. So last thing I want to do is graph these functions and the inverse. So in this case here, we have a nice easy y equals mx plus b here. I'm going to go ahead and do purple for our original and then red for our inverse. So start with a y-intercept of 3, and then we have a slope of negative 3 here. So here's our original function. Now the inverse function, which I'm going to do in red here, so we could just start plugging in some values here. So if I plug in 0 into here, I'm going to get negative 3 over negative 3, which is just 1. So if I plug in 0 for x, I'm going to get 1. Oops, this is supposed to be red. Now I'm going to go ahead and plug in 3 because I know if I get 3 minus 3, that's going to give me 0. So in this one here, 3, 0. And so what we see here is the slope is inverted as well. Instead of it being 1 over and 3 down, it's 3 over and 1 down. So really I could keep plugging in points, and we'll see that this is our inverse function.